Hello guys, today we'll discuss lead code question number 1769, minimum number of operations to move all balls to each box. So in this question we are given a string which consists of 0 and 1, and here we have to place all the balls to each of the indices and we have to find number of moves to do so. Minimum number of moves to do so. For example, here 110. If I want to place all the balls present here at index 0, number of moves that I will need is 1, because I will only move this one to the first index. Likewise, if I move to index 1, I will only need one move because I can move the left ball to the mid index. Now for the index number 2, what I will need is 3 moves, because this one placed at index 0 will require 2 moves, and the one placed at index 1 will require 1 move. So 2 plus 1, 3. Similarly here, as you can see, let's take any of the indices. Let's say I take this, okay, and I want to move all the ones at this index. So it will take 1 plus 1 2 3 4 plus 1 2 3 4 4 plus 4 8. It will need 8 moves. So we have to output the array for each index, giving the answer for each index. Okay. Now there are multiple approaches for this. Let's first discuss the usual simpler one. Okay, let's say we have this string. Okay, and I want to know the answer for this index. Okay, so what I will simply do is I will go to each and every index and count the number of moves required from there, which will be the distance between both indices. Okay, like if there is one here and the indexes are 0 1 2 3 4 and 5. Okay, so the number of moves will be 3 minus 1, which is 2. It goes like 1 and 2. If 1 is here, it will take moves 5 minus 1, which will be 1 2 3 4 4 moves. Okay, so number of moves for moving this one and this one will be 2 plus 4, which is 6. So I will add all these value, answer for all these values plus answer for the left values also, which will be let's say we have this array. Let's say I have this array. Okay, and I want to know for this index. Okay, I have one at this and at this place. Okay, and the indices are like this. All right, so answer will be 1 2 3 plus 1 2 3 4. Answer will be 7. Okay, okay, so that will be pretty simple. So the time complexity will be n square. Why? Because for each index I am iterating through the entire array, right? And I am doing this for all the indices, so it will be n into n is equal to n square. Okay, but that will work because the constants allow us to use big of n square algorithm. But we can do better here. What I can do is I can use one mathematical technique here. Okay, let's think mathematically. Okay, let's say let's say there is an index I. Okay, and I know the indices at the left, right? Let's say the indices are a1, a2, ak. Okay, let's say these are the indices, right? So how many moves will these require? It will simply be I minus a1. Let's write it instead, that will be better. So the number of moves required will be I minus a1, I minus a1 Wait, let me make it bigger. I minus a1 plus I minus a2, right? I minus a2 plus I minus ak, right? This will be the number of moves required. Now I can simplify this expression as follows. What I know is these elements, these expressions are k, right? So what I can write is, let's first make it bigger. I into k, I into k plus I into k minus a1 plus a2 plus a3 plus ak, right? I can write like this also. Okay, so what I just need to do is I will iterate through the array and I will keep track of this. I will keep track of this, and I will keep track of number of elements. And for each index, I can compute the left part first, right? And then I can in the same way compute the right part also. But that will require us to swap these values. Why? Because in that case this I will be bigger. No, sorry, because in that case the indexes that are present here will be bigger than this I, right? So I will write, I will write like this for the right part. Okay, and then in the end we'll simply return the answer. So that will take big of n time. Okay, let's try to implement this better approach. This is our answer. Okay, this will be the sum, total sum, and total elements initialized with 0. Okay, now let's move from left to right. Now for any element answer I will be I into sum minus, sorry, I into count, right? I into k, yes, you remember minus sum, right? I into k minus sum. Now as we have done the current element, if the current element is 1, if the current character is 1, we have to keep an account for that, right? So we will update our sum. S of I is 1, sum plus plus, and oh, sum plus equal to I, and count plus plus. Okay, we have done this. Now we have to do this for the elements, for the indices at the right place also, at the right word side, right? So we will again reset these values to 0 and write a loop from right to left. Now we have to reverse this part, right? So I will do is sum now, and I will also, this part will remain same, and then in the end I will just simply return the answer. Let's check if the code is correct. Yeah, So I mistakenly did this. Okay, so we are getting some wrong answer. Let's see what is the error. Mm, oh, we have to increment here, right? Not update the value, but increment. Okay, great. Now it will throw us the correct answer. Yep, let's submit the code. Yep, it got accepted. So I hope you understand the approach here. We are simply using maths to make the time complexity better, right? So here the space complexity and time complexity both are linear. I hope you like the approach, and thanks for watching, and see you with the next one. Bye.